In these video clips of lectures and also sometimes in the analysis of experiments, what you're going to see is usually just a piece of paper with me pointing and explaining what it is that we have on the paper, what it is that you're seeing. Of course, with demonstrations of experiments, you'll see demonstrations of the actual apparatus that you're going to be using to do the experiments, and you'll get some hints as to how to do those experiments. But let's talk about the relationship between experiment, reasoning, problem solving, analysis, and conceptualization. Because the way this course is designed, the central part of the course is centered around lab experiences where you do experiments and analyze them, and problems, especially the introductory problem sets and the problems in your text for those of you who will have text problems. Physics 121, the problems are just in the introductory sets. For other courses there are text problems to supplement these. And in Physics 121, of course, we just have lectures, no text, lecture notes, and your experiences. Let's start with the idea of experiment, because physics is an experimental science. In an experiment, there's something we're trying to measure. We're trying to measure something in order to see if the ideas that we have about the world are supported by experiment. Not necessarily whether they're true or false, because long experience has shown us that what seems at one time to be true is shown with greater knowledge to be less true, and maybe even false altogether. We take theories and we replace them with modified theories or sometimes completely different alternative theories. So we design experiments to test our conceptualization of the world and our reasoning. Actually, we don't test our reasoning. We assume that our reasoning processes are valid, at least when they're reviewed by our peers and so forth. But we see if the way we conceptualize the universe, the way we theorize things to be, is borne out by experiment. And in experiments, okay, we design, then we make observations. We set something in motion and we observe what happens. We get some process started and we make observations. We try to control extraneous variables, make observations of the things that we're really interested in. We carefully document what we have. We write things down very carefully, and we quantify our errors. Okay, then we proceed to analysis of our experiments, where we compare our results with our concepts and our reasoning, or compare them with our concepts through our reasoning, and we make models. The models that we use to enhance our conceptualization, our understanding, are often in the form of graphs and functions. And of course we make bigger models, theories, and so forth. But this is what we do with the analysis of an experiment, or in some cases with the analysis of a problem. Okay, so we take lab results and problems, we analyze, and we get this sort of interplay. And of course then we have conceptualization down here. Let's go up to reasoning. When we have problems, we try to reason out a solution. We don't just follow some algorithm we've learned by imitation and practice. We try to really understand what's going on. When we're confronted with a real problem, generally we're going to have to break the problem down into smaller problems. A lot of times we won't have a clue as to how to get the final result in a problem, but we will know enough to draw some logical conclusions from what we are given. And having drawn logical conclusions, that leads us to the next step, and so forth. And pretty soon we've constructed a solution by breaking down the problem, by answering the questions that can be asked at every stage. And all of a sudden the light comes on and we see that we've actually solved the problem, or we're on the verge of it. The goal here is to test our understanding against a problem and to gain intuition and common sense. To bring the understanding of a problem, especially the introductory problem sets, to the level of intuition and common sense. Then we conceptualize. Okay, by conceptualization, we try to explain the things that we observe in experiment, the things that we reason out in problems, and we try to get an overall picture that allows us to solve problems, to design experiments, to test our understanding. We try to understand everything at the level of intuition and common sense, as we do with problems. And we try to test the consistency of our conceptualizations. Everything that we are thinking about the universe should hopefully ultimately be consistent. So this is the model of the science of physics that we're going to use in this experiment, in this course. Now in the next clip we'll go into more detail on some of the quantities and relationships that we'll be studying.